Okay, today we're going to be talking about compound interest and how to use these formulas with exponentials and logs. The first thing you need to know is how to use the formula and actually what the formula is. And the formula is a variation of the original exponential function that you learned about growth and decay, but all of them pretty much are all the same formula. So stands for our ending amount, or the amount after a given amount of time. P stands for the principal, or the initial amount. R is the rate as a decimal. Time is T in years. N is the number of times it's compounded each year. Okay? And then sometimes they'll give you weird formulas and things you need to know. One of the big topics or discussion pieces is the understanding that this right here should always directly represent the number of times you will do the given thing. You'll use the percentage, but it's the actual happenings. Okay? For example, if I say that it's going to go up 3% in 5 years, or goes up 3% annually for 5 years, and it's going to compound twice a year. So if you have it for 5 years and it compounds twice a year, how many times would it actually compound? And that's 10. So then you need to make sure that that exponent up there represents 10 in some way, shape, or form. Okay? So, our first question, okay, you can read it. But you need to go through and identify all the parts. So, here, after looking at it, our initial amount is $6,500. Our rate is always given as a decimal. And so, just real quick on how you convert to a decimal, you have 8%. Okay, if you don't see a decimal place given, it's always assumed that it's here. And we're going to go away from a percentage towards a decimal. So we're going to go 1, 2, away from the percentage, put a dot, and then fill in the spot with a 0. So the decimal moves 2 places to the left when you're going from a percentage to the decimal. Okay? And so you'll need to use that philosophy for the rest of the time that you do these, because you can't enter in the 8. You have to enter in the decimal for the 8%. Okay? So now we're going to plug all these in our formula. Okay? And then just keep in mind, if it's compounded monthly, there's 12 months in a year. If it's quarterly, that's 4 times a year. Semi-annually is twice a year. Daily, 365. Weekly, there's 52 weeks in a year. So you just need to be aware of how they could do it. Bi-monthly means twice a month, so that'd be 24 times. So just be weary of how many times something happens in the given unit of time that they provide. Okay? And so if it does it monthly, that's 12 times a month for 7 years. What's 12 times 7? 84. So that means our exponent needs to be able to become 84 at some point in time. Okay? So now we'll go through and solve the equation by just typing that straight in the calculator. Okay? And that's what you should get as your final answer after you've done the work. Be wary of using the parentheses, and make sure that this is all included in the exponent. If you want to go ahead and multiply that out and use that as 84, you can. Okay? So, next question. First thing we're going to do is go through and break down what everything is. So we're going to start with 32,198 in 1998, and then in 2016, it's going to have gone up or increased to 60,000. So what's the rate of growth of the population? So you identify all your parts. So the ending amount was 60,000. The starting amount was 32,198. We don't know our rate. Our time that elapsed between 1998 and 2016 was 18 years. And then we put 1 for the compounding because it didn't give us a time frame that it compounds monthly, weekly, etc. So it's always assumed that it happens once in that year. Okay? So now we plug everything into a formula. Okay? And so whenever it's 1, you can write it in there, but I suggest that you should just know that when you divide by 1, it doesn't change anything, and when you multiply by 1, it doesn't change anything. And so just write it in the formula like this. That's also your basic growth formula, because you're doing just 1 plus r. You're not adding the compounded part in there. Okay? So now you'll just go ahead and solve that out by dividing by the 32,198 first. And you can see I did that in the calculator, pulled up the screen. Now, my suggestion is that you either keep that number in there and store it, like leave it, and then you can use the answer button, which is second and the negative key, and say A and S above it, and then that way you can work with that number because it'll help you get the right answer, like the exact answer, not the right answer, but a less rounded answer. So then I moved it off to the side, and what we'll have to do is once we've divided by this, we'll be left with 1 plus r to the 18th power. And the way you get rid of the 18th power is to take the 18th root. So you take the 18th root of both sides, and then you'll be left with 1 plus r on this side. Then you're going to subtract the 1 from both sides, and then that's what you're going to end up really typing in the calculator. So I'm going to pull that up and show you that you could just type that straight in the calculator as is. Okay? So to get to the 18th root, you'll hit math, and then you'll go down to the 5. Okay? And now I pulled up my previous answer, but we're going to change that to the 18. Okay? And then we're going to go 60,000 divided by 32,198. Okay? We're going to get out of the root button by hitting the right key, and then hit -1, not -1, and press enter. Okay? And then we'll get our rate as, I'm going to bring that down, and I'll cover that up right there. Okay? And we'll get our rate equals 0.03518 ... Okay? And what you want to do is we're going to turn our rate back into a percentage. So you're going to move your decimal 2 decimal places to the right, and you're going to get 3.5, and then we're going to use this 8 to round the 1 up to a 2%. Okay? And that's our rate. Looking at our next question, same as always, you need to label your parts so you know what you're working with. Okay, so we go through and we label. Our initial amount was 125,000. Our final amount was 356,000. Okay, the problem here is it doesn't ask us what the rate is for this given amount. That's what we're missing. It wants to know what is the value of the house on June 12th, 2018. Okay, and the numbers they give us go from 1997 to 2005. So what this is going to end up being is a two-part question. We'll have to figure out what the rate is and then use that rate to project what it would be in 2018 given that percentage rate of increase. Okay? So the first thing we need to do is establish what is our rate going to be, so then we can use that with either one of these numbers and how long it took to get to 2018 from them to find it. Okay? We'll use compounded 1 because it doesn't say an amount, so it just compounds once annually. Okay? So we plug it in our formula. Okay? We're going to divide both sides by 125,000. Then we'll take the 28th root, and then we'll subtract 1. If you get trouble about how the order went, look back at the previous question. but that's essentially what you're going to do. You'll divide by this to isolate the exponential. Then you'll take the root of the 28th to get rid of the 28th exponent. And then we'll end up subtracting 1 from both sides to leave us with the r. Okay? So you can type that in your calculator just like it is. Now you can't see the -1 over here, but there'd be a -1 there. And you'll be left with this percentage. It is my suggestion that you leave that there in the answer. You don't try to write down the rate or anything like that, so that you can use it with these numbers to make our projection for the next one. And I'll show you what I mean. So if we went from 1977 to 2018 using the original starting amount, okay, that's 41 years that it continued to grow at this percentage rate right here. Okay, so if I type that in, I just copied down what it was, but when I typed it in the calculator, I used the answer key. So that's second and the negative button. And you'll see ANS above it. That'll let you use whatever was in your previous answer inside the question. Okay? And when you do that, you end up with $578,743.89. Okay? If we do it from 2005 to 2018, that's 13 years. Okay? Using the same formula, just using 13 instead of 41, and 356,000 instead of 125,000. Type that in, and you'll see that you get the exact same answer. If you tried to compare with a rounded decimal for your percentage rate, then it would not give you the exact same number. They'd be off, and then you'd be like, well, which one's right? And so theoretically, they're both right when you use the exact percentage rate. Okay? So the final answer should be $578,743.89 as the exact answer. Now, it may ask for an approximated value, and you probably can round and get really close to it with the other ones. But this is the exact answer given the exact information here. Okay? So, suppose someone was investing $4,000 or has $4,000 from investing in an account that pays 2.3% and is compounded quarterly. Quarterly means it's 4 times a year. Okay? At the end of 7 years. How much did she start with or initially have? So we're looking for the principal here. So when we plug everything in, 4,000 was actually the ending amount. She got it from investing. We don't know how much you started with, and you've converted all your rates. Remember, quarterly is 4, and so then you plug it into your formula here. So this one is one of my favorite ones to do because it's the easiest. You can solve this in one step. Since P is what we're looking for, and it's being multiplied by all of this, all we have to do is divide by all of that. So you'll just take this. I go ahead and I multiply that out to get the 28. But really, all you have to do is 4,000 divided by all of that. And so the way you want to do that in a calculator is use alpha y equals enter. And that'll give the little ... over ... thing. So that you can enter it in and it'll keep it separated. And it makes it really easy. So these are my favorite ones because they're the easiest ones to solve. So this is the same structure. She got this much from investing. Okay, so I want you to take your time and answer this question on your own. You can pause the video, answer it on your own. Okay. Okay, so first you label all your stuff. Okay. Then you plug it in your equation. And then you divide everything by it. Remember that you can multiply these out and go ahead and get the 36. And then plug it straight in your calculator using alpha y equals enter. And keeping stuff in parentheses. Okay? So now here's where we get into the meat and potatoes, why we put this in the exponential logs unit itself. Okay, this is the one I tried to go over at the end of class yesterday. It says approximately how many years will it take for $2,000 to double if it is invested in an account that pays 2% compounded quarterly, round to the nearest whole year. Okay, so the first thing you're going to do is go ahead and label everything. Okay, so our ending amount is going to be $4,000 because that's $2,000 doubled. Our starting amount is $2,000. Our rate is 0.02. Our compounding is 4. And the time is the thing we don't know. Okay? Plug that into our formula. And you're going to divide it. Now, one thing I want to point out is, what did it say we were going to do with our $2,000? We said it's going to double. Notice how that's a 2. And you'll see this more in our second example as well. So a little shortcut you can do is whatever it's going to do, that's what it's going to be here after the first step anyway. Okay? But if you don't think you'll remember that, it's okay. It'll always work out in the end if you do it the extended way. Okay? So we divide the 2,000 to get our exponential by itself, but now we notice that we have a letter in the exponent. And how do you get letters out of the exponent? You use the log. So we take the log of the base, okay, our base being this whole parentheses here, okay, so the log of the base, and then the exponent and the number that it equals on the other side switch spots, okay, and then we're going to divide both sides by 4, and I'm just going to drop this down, and then you just type that whole thing right there, okay, let me circle this up. So that whole thing right there just gets typed in the calculator. I'm suggesting that you use alpha y equals to get your fraction bar, and then it's math alpha math is the shortcut for the log. And it'll go log, and then it'll give you a base, and then it'll give you the actual thing you're taking the log of. Okay? And then we get 34.7, since it said round to the nearest whole year. 34.7 rounds up to 35. Okay? Same basic question. Okay? $5,000 triples. You're using 3.4% compounded monthly. Okay? We're going to need the nearest whole year. Okay? So write everything down, plug it in. Remember I said the shortcut was it's going to be 3 because you tripled something. Okay? And then we divided by the 5,000 to get the 3. Okay? And when you try to get the exponent out of the letter out of the exponent, you do log, and the exponent and what it equals just switch spots. So this is still the base, that goes above the base, and you have what it equals, and then you're going to divide by 12, and when you type all that in the calculator, you end up with 32 total years. Okay? Alright? So here are ones where people get confused on because they don't see how the years transpire in this one. And so when you're looking at this, pay attention when you're trying to label it that it says there are 45,000 coyotes now. This current year is 2019, so that's why we'll use this here. Now, as you watch this video, this could be way in the future now that I've left this on my website for so long, and it's not 2019, so you might have to adjust your question based on when it is for you. Okay? So then you plug it all in the formula, and you're just going to work it out like normal. The keys that we're going to work with here is we're going to focus on growing versus decreasing. Okay? And so when it's growing, our percentage is going to be a positive percentage, and when it's decreasing, our percentage is going to be a negative percentage. Okay? So looking at that second question down here, says the population of the deer is decreasing because the coyotes are eating them, and since they're growing, the reindeer are going to decrease. Okay, so currently it's 2019, another thing. Okay, and from 2019 to 2005, that's 14 total years. Okay, now this one says that there are currently 21,000 deer. How many were there in 2005? So that's previously. So this would be the start, and this is where we've gone to. Okay? So now, over the time, the deer have decreased. They're going down from the start. Okay? And then you get this answer here. When you plug it in, so you plug it into the formula, you got your decrease in population. Okay, over the 14 years, you go through and solve it. Sorry, I thought I'd pause the video. I was working to see if it could go backwards, just to see. That was my bad. I thought I'd pause the video, but apparently I did not. Okay, I just wanted to see if it would work if you tried it from 21,000 to go up to it, just to see if I could give you an alternate way to do it. That's my bad for not pausing the video. So tell your friends that they can skip that. It was at the end of the video anyway, because that was the last question. Um, so just work on the worksheets and all the stuff that you needed to do, and I'll see you in class tomorrow.